Hello. In this video, we are going to derive the integrated rate law for a third-order reaction and calculate an expression for the half-life. For a third-order reaction with one reactant A, the rate of the reaction is equivalent to minus K times the concentration of A to the third power. To solve this differential equation, we use the technique of separation of variables. We multiply each side of the equation by dt and divide each side by the concentration of A to the third power. As a result, we get all the terms that involve A on the left-hand side and all the terms that involve T on the right-hand side. Next, we integrate each side, the left-hand side from A sub 0, this is the initial concentration of A, to the concentration of A, and on the right-hand side from T0, the initial time, to the time T. And we're making the assumption that the time 0 is actually 0. So now we have to integrate the left-hand side with respect to A and the right-hand side with respect to T. On the left-hand side, the antiderivative of 1 over A cubed is going to be minus 1 over 2 times the quantity A squared. And on the right-hand side, the antiderivative is going to be minus KT. Now we apply the fundamental theorem of integral calculus, and we evaluate the left-hand side and the right-hand side between the appropriate limits. So evaluating at the limits of the concentration of A or the concentration of A sub 0, notice that we have minus 1 over 2 A squared, and then we have a plus sign because we have minus a minus. So now we have plus 1 over 2 times the concentration of A sub 0 squared, and the right-hand side becomes simply minus KT. If we multiply each side of the equation by a minus sign, we get our integrated rate law, 1 over 2 times the concentration of A squared minus 1 over 2 times the concentration of A sub 0 squared equals KT. Next, we're going to derive an expression for the half-life of such a third-order reaction. By the definition of the half-life, that is when the concentration of A is equal to half of the initial value. So we're going to assume that in our integrated rate law. And the time where this occurs is, by definition, the half-life time. So if we substitute for A, concentration of A here, the initial concentration A over 2, we square that term, and then because it's in the denominator, it comes up to the numerator. So we get 4 over 2 times the concentration of A initial squared, minus, this term doesn't change at all, 1 over 2 times the initial concentration of A squared. And then on the right-hand side, we simply replace T by the half-life time T1 half. On the left-hand side, both of the fractions have the exact same denominator, so it's straightforward to subtract to get 3 over 2 times the initial concentration of A squared, and the right-hand side remaining K times the half-life time T sub 1 half. Lastly, we divide each side by the rate constant K to get that the half-life time is going to be 3 over 2K times the initial concentration of A squared. Again, we notice, since this is not a first-order reaction, that the half-life time does depend upon the initial concentration. I thank you very much for your kind attention. Stay safe, and as always, have a good one.